Welcome to the first lecture in Unit 3 entitled The Elements of Organization. It says the achievement of an organizations are the result of the combined effort of each individual by Vince Lombardi. So the first thing we want to do is look at our learning goals, and the students will be able to write the chemical symbol or name for all of the 114 elements. Now that's with a periodic table. You are not expected to memorize all 114 elements. Instead, there's a specific few, the 14 common chemical symbols and names that you should be able to describe. Also, you should be able to describe the historical development of the periodic table, including early forms and how it modernized based on experimental evidence. So what we already know. We already know that atoms are elements consisting of protons, neutrons, and electrons. We also know that the periodic table is used to classify elements based on properties. And we also know that properties can be divided into physical or chemical properties based on whether it's reacting with something else or whether it is independent whenever we talk about physical properties. So what we learned in the lab, we know that the periodic table can tell us the number of protons, neutrons, electrons, and even the electron orbital. What we learned is in essence that the periodic table is a giant cheat sheet, where if you know how to properly use the periodic table, you can get a lot of information out of it. Okay, so what we know. Atoms are the smallest form of matter that maintain unique physical and chemical properties. You can go smaller than an atom. An atom is not the smallest form of matter. That would be protons, neutrons, and electrons that are smaller, and there are things called quarks, gluons, and bosons that are smaller than that. But they are the smallest form of matter that maintains a unique property. In other words, this right here would be an example of looks like a lithium atom. Okay, and so every lithium atom has unique chemical and physical properties. If you were to take a look at protons, all protons are identical. So if we were to look at the protons of lithium and the protons of hydrogen and the protons of uranium, they'd be the exact same. So even though we have smaller versions of matter, the atom is considered to be the fundamental unit because it's the smallest one that maintains the properties. Elements are defined as a pure substance. They contain only one type of atom. And that's the key thing right there. Only one type of atom. The IUPAC, which stands for the International Union of Pure and Applied Chemistry, currently recognizes 114 different elements. Now, this 114 elements, this is the governing body for this. So whenever somebody says, hey, we think we discovered a new element, they submit their information to the IUPAC, which determines whether or not they actually did discover a new element. Whenever we talk about chemical symbols, all elements have a unique name. You see Darmstadtium right here. The name is often shortened to the chemical symbol, and the chemical symbol is often what you see, where DS is Darmstadtium. If you were to look at carbon, carbon would be C. So usually there's a capital letter for sure, and sometimes there's some lowercase letters after that, but sometimes there's not, like carbon, oxygen, nitrogen. You are responsible for naming and writing the chemical symbol for the elements below without a periodic table. You should be able to recognize these 14 elements. They are the most common ones that you will see in this class and later in chemistry. So you should know that H is hydrogen. You should know that Li is lithium. Na is sodium, K is potassium, and that's a tricky one because it's K is potassium. For the most part, they tend to go with a name. So F is fluorine, P is phosphorus, S is sulfur. But you tend to see there are things like potassium in which doesn't quite match up. Okay, these are the 14 most common elements, and you do need to know not only where they are in the periodic table, but their symbol and their names as well. So the properties of elements. All elements have an identical chemical properties and identical physical properties. So if I have an atom of gold here, gold is Au, and an atom of gold here, there is no way to distinguish between these two atoms because they're identical. Identical chemical properties, identical physical properties. That's what we mean by an element. So it says match the symbol to the name of the elements without a periodic table. So this is starting to practice kind of what we have going on. So the first one is nitrogen is really easy. It's the one with the N. The rest of them are a little bit tricky because if you were to look at potassium, you've got P, but you also have a P that starts with phosphorus. And you're supposed to recognize and say, okay, well, phosphorus is P and potassium is actually K, and that leaves sodium as Na. So you need to be able to recognize these symbols very, very quickly and name them appropriately. It says state why the definition for the atom below is incorrect and then modify the statement to make it true. It says the atom is the smallest unit of matter. Okay, that is untrue because of the fact that you have things that are smaller, like protons, neutrons, electrons. You have quarks, you have bosons, you have leptons. There's lots of different things of matter that's smaller than an atom. Okay, what we can do to modify this statement to make it true is we can say that retains unique properties. By saying that, we're saying that the atom is the smallest thing that you can say, hey, that is still gold, or that is still hydrogen. If you break it down any smaller into protons, leptons, bosons, neutrons, it doesn't matter. Those things are no longer unique to particular elements. This is using a periodic table. Write the name of 4 elements you would find in a car. Okay, so the first thing, you would generally see aluminum. Okay, so we say aluminum is Al, and we could write it as aluminum. Okay, the next thing that we would generally find, like in gas, in a car would be carbon. C is carbon. You also tend to find iron in cars because iron is used to make steel, so we'd say Fe, and we would say that that is iron. You also tend to find platinum. Platinum is usually in the catalytic converter that is used to reduce emissions, so we say we have platinum. Now you may have chosen other elements. You could have said silver. You should have said copper for wiring. You could have said zinc in the battery. You could have said lithium in the battery. You could have said there's oxygen in the cabin. You could have said or oxygen in the tank in order to have combustion occur. There's lots of different elements that are involved in a car, and you should be able to recognize ones that are there. So now it says write the chemical symbol of 10 elements your body needs to function properly. So that's easy. We are a carbon-based life form, so we need carbon. We also need oxygen to survive, so we need O. In addition to that, we need nitrogen. Nitrogen is the primary component of amino acids, which are proteins. We also need iron for hemoglobin in our blood. We also need hydrogen. Hydrogen is really found attached to carbons for the most part. We also need things like sulfur. We need phosphorus. Okay, we also need trace amounts of other minerals, like we do need trace amounts of manganese. Okay, we also need some amounts of cobalt. Okay, so we're at what, 9 now? So if you needed another one, you can look in and say, okay, what else do we need? You're not quite sure. You also need fluorine generally to help with your teeth. And you also have small amounts of chlorine in your body as well, although not very much because too high amount of chlorine is actually lethal to you. So the history of the elements. Some elements have been used since the beginning of recorded history. We have iron, gold, silver, copper are all examples of elements that have been found relatively easily, and they've always been around. So you see this, you have gold coins, you have copper coins, you have silver coins, you see the iron tools and things. Okay, the first discovered element that was synthesized was actually synthesized by Henning Brunnen in 1649, and he actually discovered the element phosphorus by taking his own urine and boiling it until it became a solid. So basically what he did is he removed all of the water from his own urine. And then what he did is he heated that until the solid actually changed its consistency. And whenever the solid changed its consistency, he was able to continue purifying it by heating it and removing things and heating it and removing things until he came to a green glowing solid compound. And that's what we now know as phosphorus. Joseph Dauberner, he was the first one who actually organized elements in what he called triads, where he would say strontium, calcium, and barium, he would consider to have one triad, that 3 elements had very similar properties. And these similar properties he noticed always occurred in patterns of 3. Now, these similar properties did have different mass, but he considered them to be the same element, but different versions of them. So you had like a light, a medium, and a heavy version of these things. Next, we had John Newlands, and John Newlands was actually mocked at the time for relating his organization of the elements to music. And what he did is he suggested that the elements of Similar properties were basically saying that you move up and down a music scale. So he said, you have calcium and you have strontium and you have barium, and all those what those three elements would represent is you have a low C, a middle C, and a high C, very similar to a musical section. So you have, yes, this is C. I'm not a music person, but you have C, and then the next one that you have is a C up here, and the next one you have is a C up here, and there are different elements that go along just like musical notes. Then you come to Mendeleev, and Mendeleev is considered to be the father of the periodic table. He was the first one to actually systematically organize the elements in such a way that you can predict a pattern. That's the reason why he was actually considered to be the father. He's the first person to not just take what was there, he actually left gaps in his periodic table saying, you know what, we haven't found this yet, but there is going to be an element that's going to be discovered that will go right there. There's going to be an element that will be discovered that will be right there. And in fact, during his lifetime, after his organization of the periodic table, there were several different cases of elements being found right where the gaps Mendeleev left in his periodic table were. Now, we don't use the periodic table of Mendeleev. We actually use more closely to a version of Moseley. Moseley was one who said, okay, Mendeleev organized it by mass, but whenever you organize it by mass, there's some inconsistencies. So Moseley actually organized his periodic table by atomic number, which is the number of protons. And in doing so, he removed all the inconsistencies that Mendeleev had in his periodic table. And what he's found out whenever he did this is that you can line things up vertically, and they have very similar chemical properties. So everything vertically has the same chemical properties, and there are no inconsistencies in terms of, well, this should really be here or anything like that. So Moseley's periodic table was much, much more accurate than Mendeleev's. And the final thing we needed to do is we actually needed to include something called the transuranium elements. And the transuranium elements are what we now know as the f orbitals. They're these bottom elements that are pulled out of the periodic table. They were actually discovered by a guy named Seaborg, and Seaborg actually has his own element now as to recognize the contributions that he had to the periodic table. Like I said, these are the ones that are pulled out at the bottom of the periodic table. We won't use them very much in this class, but it is kind of the final piece of the periodic table. Now, you should bookmark the site ptable.com today because it's going to be very useful in giving you information that you need in order to move through the rest of this class. Okay, the IUPAC is the International Union of Pure and Applied Chemistry, and they are responsible for the official periodic table. They are the ones who name elements and they verify their presence. So if you believe you came up with a new element that has never previously been discovered, then you would submit your information to the IUPAC and it would go through a process of peer review where they would actually try and develop the same element according to the method that you described. And if they're successful in finding out that yes, it is in fact true, they will actually say, yes, we have a preliminary name, and we'll give it a name such as like UUO. And UUO would be an example of element 118. And that stands for un octium. So 118. And once you do that, they'll discuss naming this particular element. Now, sometimes the person who discovers the element has a say in what it's going to be named, but ultimately it's up to the IUPAC. And the last one was actually called livermorium, and it was actually discovered or released in 2000. This is the symbol for the IUPAC. So you see some of the uses of chemistry. So you see kind of a world outlook. You see a balanced chemical equation. You see a canon, which is where a lot of chemistry actually developed out of, was the development of gunpowder and those sorts of things. And then you see this right here is kind of a traditional symbol for alchemy, where you see in a beaker.